Okay, so what we're talking about here is the activity series, and as I've just shown you, I've got four beakers with different metals in a copper sulfate solution. And what we just talked about was the fact that when you have zinc in this copper sulfate solution, we have a reaction that looks something like this: zinc solid plus copper 2 sulfate. And copper 2 sulfate, that's pretty soluble, so that's why we're going to put aqueous there. Okay? So that's what we have. And we see inside this, and I'm just going to grab it here. Which one is it? It is zinc. Okay. So here's the zinc, and what we see in there is that it was a clear, shiny piece of metal, and it's very dark and black, and we've got all sorts of things in there. The solution is not a brilliant blue that it started out as, right? And here is the aluminum. So aluminum foil in there, and we definitely have some copper inside there, and it's flaking off, falling apart. Okay? The activity series tells us when this is going to happen, if a reaction is going to happen here at all. And because zinc sulfate's fairly soluble, and copper sulfate's fairly soluble, what happens here? And actually, this is a single replacement reaction where zinc kicks out copper. How do we know zinc kicks out copper? In front of you, you have this little chart. And what we want to do, what I want to point out here, is that if you look at this chart, it's called an activity series, and we have a listing of metals. And the metals that are higher up on this chart are more active than the ones that are lower. So if we have, in this case, we have zinc, which is right here, and it is higher on the chart than copper. Okay? And so what's going to happen is zinc will displace copper. It's more active. It's more readily wanting to change into an ion. That's what that means. Okay? Now, we are in the redox unit here, and so I'm going to talk more about this oxidation reaction and why we have electrons in a chemical reaction. That's what redox is all about, reduction oxidation. So we're going to talk more about that as we move through, but I just wanted to cover this activity series and show you just a little bit about what's happening in these beakers. So of course, this is becoming very dark, and the copper sulfate solution is actually changing color. It's quite a bit lighter than it was before. And so what we have here is we have zinc sulfate. Okay, and yes, it's dissolved a little bit, but the biggest thing is we have copper solid. Okay, and that's what the black stuff is, and it's kind of black, really dark brown, whatever, copper solid. So that's a little bit about the activity series, and that leads us into redox reactions. Now these are special type of reactions. Okay, there's a category, obviously, single displacement, but what else is happening that you're not aware of is the fact that electrons are being transferred, which we've never really talked about before. So that's what this whole lesson is about. Zinc is a solid here, but notice on the other side, it's an ion. And over here, copper is an ion, which has a charge, and now it's a solid, which has no charge. Okay, so if I could just rewrite this, it looks kind of like this. Zinc solid, you guys don't have to write this, but I want to do this, is really, this is what we have. Sulfate, copper, and we're producing now copper solid with zinc ions and sulfate ions. And so this is what I want, is really important here, is that the zinc solid becomes a zinc ion. Now to go from a solid to an ion, there's been some transfer of electrons. Has zinc solid given up or accepted electrons here in this process? Sorry? Given up. So zinc is neutral here, and now it's 2 minus. So you see it just got rid of 2 electrons to become positive. Sorry? What else has changed here? Well, we've got the copper solid, and this is an ion here. So what's happened to the copper 2+ ion to become solid? Well, it has accepted. So guess what? We have 2 electrons being transferred here in this reaction. So that's an example of a redox reaction. And of course we have aluminum, we have the steel wool, which the steel wool is quite, that steel wool is very reactive. There's lots of surface area, right, for the reaction to happen with steel wool. So it has drawn, really it's drawn the copper out of the solution, right? The copper sulfate was a very pleasant sort of blue solution like you see here. And those ions, when they accepted those electrons, became solid, and the property is changed of that solution. Okay, so that's the activity series. I'll go back to that picture, and you have that in front of you. And so a single displacement is going to happen if a metal reacts with an ion that is lower on the chart.